Good morning, everyone. I am Maheswari, AP Department, RMD Engineering College. This video, I am going to discuss about the topic sensors and transducer in the fifth unit. It is signal conditioning and data acquisition system. So, in signal conditioning and data acquisition system, we are going to discuss about the particular topic, that is the multi-channel data acquisition system. So before sharing what is multi-channel data acquisition system, we must understand what is data acquisition system first. So data acquisition system, it is a system which is used for data processing, data conversion, data transmission and data storage. So you can understand here, data acquisition system is the process of using the output signals and inputting that into a computer. So the output signals may be one that is originating from the direct measurement of electrical quantities, the electrical quantities such as voltage, frequency, resistance, etc. So a data acquisition system consists of sensors with signal conditioning, multiplexing, data conversion for data processing, data handling, and the transmission and storage and display systems. All these consist of data acquisition system. So the analog data which is required and with whatever the analog data which is obtained are to be converted into digital form for the purpose of processing the data, transmitting and displaying the data and storing the data. So the data which is transmitted for long distance, that is from one location to another location, or for short distance, that is from a test center to a computer, we need all this process to be done. The data has to be displayed on a digital panel or a cathode ray oscilloscope or in a CRT presentation. We need to store the data temporarily. So for that, we need the process of storing the data. So in data acquisition system, the different types of data acquisition are analog data acquisition, digital data acquisition, automated data acquisition, single channel data acquisition, and multi-channel data acquisition. So now we are going to discuss about the multi-channel data acquisition system. So in multi-channel data acquisition, the time is shared by two or more input sources. See, there will be more amount of input sources. Among those input sources, the time is shared by two or more inputs. So depending upon the properties of the multiplexed system, number of techniques are used for such time sharing measurement. So among that, the first method of multi-channel data acquisition system is the multi-channel analog multiplex system. So going to that topic, multi-channel analog multiplex system. So this multi-channel analog multiplex system has a single A to D converter. Okay, it has a single converter, analog to digital converter, and it is after this multiplexer. It is after this multiplexer, and it is, you can see in the diagram. Now this analog, individual analog signals, you have analog signals. There are many analog signals. In this diagram, we have four analog signals, which is directly given to this, the scaling, amplification, and the signal conditioning, and then it is given to the multiplexer. Now they are converted into, using this signals are transferred, these analog signals, after is required scaling, amplification, and conditioning of the signals such as filtering, and this is sent to the multiplexer. After this multiplexer, among the many input signal, one of the signal which has to be transmitted is sent, and it is sent to the digital to analog converter, where we are using here an analog to digital converter we are using here, where the data is converted from analog pattern to digital. Now for the most efficient utilization of time, the multiplexer is made to check the channel and convert it while the previous data is stored. So for that, we are using the sample and hold circuit. In order to have a time saving and efficient utilization, we are storing the data, we are sampling the data and storing the data, and then we are converting into a digital form. So this conversion, whenever this conversion is complete, The status line from the converter causes the sample and hold circuit to return to the sample mode and acquires the signal for the next channel. They'll acquire the next channel signal. Now, after the completion of this data acquisition, and the sample and hold circuit is switched to the hold mode. The conversion begins again and the multiplexer selects the next channel. So this method is slower than a system where sample and hold outputs and even A to D converter outputs are multiplexer, and whereas it is advantageous because of its low cost due to sharing of majority of the subsystems. So this is the first method of multi-channel data acquisition system, that is multi-channel analog multiplex system. Next one is multiplexing the output of sample and hold circuit. Here you can see that the analog input after signal conditioning is given to the different sample and hold circuit. So the large number of channels are to be monitored at the same time. So at the same time, but the speed is moderate speed. The technique what we are using is multiplexing the output of the sample and hold circuit. So it is very beneficial and it saves times, multiplexing the sample and hold circuit values. So here in the previous diagram, a single SNH is assigned. Okay, single SNH is assigned. Here, the analog signals are given to the different SNH, and the output of this sample and hold circuit is given to the multiplexer. The SNM, the sample and hold circuit outputs are connected to the multiplexer and then to the analog to digital converter, and it results in a sequential readout of the outputs. So the application, it is used where the approach includes wind tunnel measurements and radar and fire control systems and measurement of one shot phenomenon and critical point during one shot event. So these are the different applications of this multiplexing the outputs of sample and hold. The next diagram or the next type is multiplexing after A to D conversion. So the here this you can see that the analog signal is given to the sample and hold circuit, and then it is given to the analog to digital converter, and then the with respect to the timing, the data is given to the multiplexer. So it is here economical to employ the A to D converter for each analog input and multiplex the digital outputs. So this is the process what is followed in this. After the conversion of analog data into digital data, this digital data is multiplexed. And here you can see that for each analog to digital converter is assigned to an individual channel, and the conversion rate of A to D need to be fast, and as it is needed for that channel to compare with the higher rates that would be needed if it is used for a multi-channel analog multiplex systems. So the parallel conversion scheme provides additional advantages in industrial data acquisition system, where many strain gauges, thermocouples and LVDTs are used in the plant. Now, these analog signals are digitized at the source. The digital transmission of the data to the data centers can be provided with enhanced immunity against the line frequency and other group loop interferences. So, the data converted to digital form is used to perform logical operations and decisions. Based on the relative speed at which the changes occurs in the data, the scanning rate can be increased or decreased. Alternatively, here the input channels having slow varying data can be pre-multiplexed in any of the forms as said in the before procedures. So here we are using this data acquisition system after the analog which is converted to digital data, and then it is sent to the multiplexer, digital multiplexer. The next type is multiplexing the low level data. So a low level data multiplexing system, this is your block diagram of it. This system enables the use of single high quality data amplifier for handling multi-channel low level inputs. So the individual amplifiers are used for each low level signals. The low-level multiplexing it is attractive in a large number of channels, say channels greater than 20 or 25, all having low level outputs need to be used at a moderate speed. The use of individual channels is possible because of the availability of high quality amplifiers. So the application is it is widely used. The several factors to be considered to accomplish the low level multiplexing successfully. Guarding may have to be employed for every channel and each individual guard have to be switched. So here you can see the guarding. Okay, and each individual guard have to be switched so that the appropriate guard is driven by the common mode pertaining to the channel. So it need to be carried out. So when the number of channels have to be multiplexed, this increases the problem of stray capacitance and capacitance balance. So in specific case, a 48 channel system, the input channel is separated into 8 channels multiplier on the same tier. So the advantages of this system is the reduction of capacitance effect. So in this particular session, we have seen about multi-channel data acquisition system and its types. The first type is multi-channel analog multiplex system, and multiplexing the output of sample and hold circuit, multiplexing after analog to digital conversion, and multiplexing the low level data. Thank you everyone.